Okay, now we're doing question 11 on section 3.1. And we're given this function, and we have to use the definition of the derivative to find the slope of this curve at the point 2, 5, and then find the equation of the tangent line through that point. So, we need, as you can see for this definition, we need f of x. Well, we have f of x right there. We need f of x plus h. Well, let's build that. And so f of x plus h equals, and you know how to do composite functions. We put x plus h there in place of x. We square it plus 1. Which equals, when you FOIL this out, you get x squared plus 2xh plus h squared plus 1. Make sure you're satisfied with that. Now, let's find the slope. So therefore, f prime of x equals the limit as h goes to 0, and we have an h downstairs. Now we have to employ f of x plus h, install its identity. Well, there it is. X squared plus 2xh plus h squared plus 1. Now minus f of x. Well, f of x is x squared plus 1, so if I multiply that by a -1, I get minus x squared minus 1. Now notice the 1's add out, the x squareds add out, and we're left with 2xh plus h squared. Now we can factor an h out of each of those terms, and we get 2x plus h all over h. And now the h's divide out, these two, and so we no longer have the likelihood of a division by 0. So now, when we let h be 0, we can let h be 0 right here. All we get back is 2x. And so then, we've got this point here. We've got to find the slope of the curve at that point. Well, the x-coordinate's 2, so f prime of 2 is 2 times, and replacing x with 2 times 2 is 4. So there, we've got that. Now we have to come up with the equation of the tangent line, and we'll use the point-slope form of the line, which is y minus y sub 1 equals m. In fact, why don't I do it in terms of f? So, no, I'll do it in terms of y. Y minus y sub 1 equals f prime of x sub 1 times x minus x sub 1. There we go. Okay, so we've got y minus, and the y value is 5, equals, and the slope is 4, times x minus 2, that 2 right there. So now let's expand this, so we get y minus 5 equals 4x minus 8. And now adding 5 to both sides, we get y equals 4x minus 3, and we are done. Okay, now we're doing question 27. And so we're told we've got a height of f of t equals 100 minus 4.9 t squared. And we're going to drop an object from this tower. That's how high the tower is, 100 feet. And we want to know how fast that object's falling after 2 seconds. And so we've got f of t, and by the way, we have to use the definition of the limits. So we need to find f of t plus h And so that's going to equal 100 minus 4.9 times, and that's going to be t plus h squared, so I'm just going to go ahead and square that as we did in the last problem. So that's going to be t squared plus 2ht plus h squared. Okay, now, so f prime of t is going to equal the limit as h goes to 0 of, and we have to install f of t plus h, so that's going to be a 100. And I'm going to go ahead and multiply through by negative 4.9, so minus 4.9 t squared. Doubling negative 4.9, we get 9.8 ht minus 4.9 h squared, and then we're going to subtract this, so if we multiply 100 times a negative, we get negative 100, and if we multiply negative 4.9 t squared by a negative, we get a positive 4.9 t squared. Now notice, the 4.9 t squareds add out, the hundreds add out, and we're left with two terms involving h. So we've got the limit as h goes to 0, and we'll factor an h out of each of these terms. In fact, we'll factor a minus h out of each of these terms. No, I'll just factor an h out and be done with it. So we've got h times minus 9.8 t minus 4.9 h all over h, and those h's divide out, and now we'll let h go to 0, so that'll wipe out this term, and that'll leave us with negative 9.8 t. So there's our slope. Now we want to know how fast, and by the way, so this is also the velocity, so I'll write f of t is v of t, and by the way, that's f prime of t, so error on my part, f prime of t. So that is the velocity, and that's negative 9.8 t. And now, what's the velocity after 2 seconds? Well, that's going to be negative 9.8 times 2, which is negative 19.6. And what are our units? That's going to be meters per second. Meters per second, yeah. Okay, so that's the velocity. That's v of 2. Good.